everyone. So we are going to learn how to multiply fractions today, and we're also going to learn how to model the products that we get from those steps. We're also going to review greatest common factor and how we can use the greatest common factor to simplify our fractions. Let's go ahead and get started. So there are some things I want to go over before I show you the steps. Sometimes it helps to know, why are we even learning this? So when would we need to multiply fractions together outside of a math class or outside of this math class that you're currently in? Some of the things I could come up with were baking. If you ever baked or cooked with a grown-up at your house, you know that you have fractions that you have to put in the measurement cups, and that really helps, especially if you have to multiply a recipe for a whole class or for your family or for a big group of people. So you definitely would need to know how to multiply fractions whenever you are baking or cooking. Also building. If you are building and you're into a STEM class, you might have to measure and build things, and sometimes the measurements have to deal with fractions. You have to multiply those fractions. You also have to add, subtract, divide those fractions, so it's important for that. Telling time, people might tell you, oh, it's a quarter of an hour, which is a fourth of an hour. Knowing the fraction lingo would help you with that. Weight and measurement, your middle school math class coming up next year, or maybe you're already there. Your high school math class, which is coming up in a few years for you, or maybe you're here as a review. And if you decide to go to college, you will definitely see this in college as well. And you'd be surprised how many adults don't remember how to do this. So help yourself out and remember how to multiply fractions. So how do we multiply fractions together? So if you have a whole number, you're going to have to write that as a fraction. So let's say I have this as my problem. Let's say I have 6 times 2/3. So this 6 that we see right here, I'm going to have to turn that into a fraction. So I'm going to put 6 over 1 because it's 6 parts to 1 whole. 6 divided by 1 is 6. It's the same thing as saying 6. And 2/3 stays the same. Okay, your second step is to multiply the numerators together and then multiply the denominators together. So we multiply across, essentially. I'm going to rewrite it. And, just for keeping my work organized, I'm going to use a different color so that it's not confusing. So I have 6 over 1 times 2 over 3. And I multiply across. So whenever I multiply across, 6 times 2 gives me 12. And then 1 times 3 gives me 3. My final step is to simplify. So you can think about simplifying in a lot of different ways, and we're going to review that a little bit more in the next few slides. But I'm going to think about simplifying as a fraction, thinking about my fraction as a division problem. So 12 over 3, or 12/3, is also the same as saying 12 divided by 3. So 12 divided by 3 is 4. So my final answer is 4. Okay, and again, before we review the simplification of fractions, I think it's important to know why we do that. So when you need to simplify a fraction, it's a courteous way to show your answer and is technically the most correct. Your teacher may not give you full credit if you don't simplify your fraction answer, so review the steps in the next slide to make sure that you earn that good grade that you want. So for step 1, we find the GCF of the numerator and the denominator. So let's say that I have the answer 3 over 12. So we're not going to do the actual multiplication problem. Let's just say that my product, or my answer, is 3 over 12. Well, that's not in simplest form because I can make this in smaller terms, so it's the most correct. So we need to find the GCF. The GCF is whenever you make that t-chart for each number, for the numerator and the denominator, and you multiply. So we have 1 times 3, and then 3 times 1, and that's pretty much it for 3. And then for 12, I have 1 times 12. I have 3 times 4. I have 4 times 3, 6 times 2, so on and so forth. And the greatest common factor, which is the factor that they have in common that is the highest, is going to be that number 3, which I see here and here. So what that means is that I am going to divide each number, so the numerator and the denominator, by that GCF. So divide both the numerator and the denominator by the GCF to find your answer. So we had 3/12, and our GCF on the previous slide was 3. So I'm going to divide 3 by 3 and 12 by 3. Essentially, what you do to the top, you also have to do to the bottom. So we're dividing both by 3. And my final answer, 3 divided by 3 gives me 1. 12 divided by 3 gives me 4. And I know that I'm done because my numerator is 1, so I can't really get much smaller than that. And my denominator is 4. So my answer is 1/4 if I'm simplifying my fraction. So now that we've so let's try an example together. So let's say I have 5/6 times 2/3. Okay, my first step is to multiply the numerators. And then I'm going to multiply my denominators. So 5 times 2 gives me 10. And maybe put a multiplication sign there to help yourself. So 5 times 2 gives me 10. 6 times 3 gives me 18. And that's technically my answer, but it's not the most correct because I have to simplify. So I'm going to find the greatest common factor of 10 and 18. Some people like to find a common one in their head and keep on dividing until they can't divide anymore. I'm going to use the t-chart method because it is a foolproof way to make sure that it is reduced in lowest terms. So I'm going to take my numerator, which is 10, and I'm going to do my t-chart. So 10, and then I have 18 as well for my denominator. Okay, so I have 1 times 10. I have 2 times 5, which gives me 10. 3 won't go into 10 evenly, 4 won't, 5 will, and we kind of already wrote that above. 5 times 2, 2 times 5. 6 can't go in, 7 can't go in, 8 can't go in, 9 can't go in, and then we have 10 times 1. So that's it for 10. For 18, I'm going to extend my line here. 18, I have 1 times 18. I have 2 times 9, 3 times 6, 4 can't go into 18, neither can 5. 6 can, 3 times, 6 times 3. 7 can't go in, 8 can't go in, 9 can go in 2 times. And then we have 18 and 1. So out of all of my factors that I see here, I can see that the greatest common factor between 10 and 18 is going to be that 2 that we see. So that 2 is the biggest number that they have in common. What that means is that I'm going to divide 10 by 2 and divide 18 by 2 to get my final answer, which I'm going to write in below. So 10 divided by 2 gives me 5, and 18 divided by 2 gives me 9. So the answer to 5/6 times 2/3 equals 5/9. And it's always a good idea to circle your answer. Even if you're virtual and you're showing your scratch work, circling your answer if you ever go back to face-to-face will help out your teacher and probably give you a better grade because it can see your answer better. So going back to our very, very first problem, I'm going to show you how to model 6 times 2/3. So I'm going to write my problem just so we have it for reference. 6 times 2/3. And our goal here is to model what the answer would be. So you already know that the answer is going to be 4 because we already solved this earlier in the video, but you're going to think of it in a different way. So this symbol right here, the multiplication symbol that we see right here, another word that we use whenever we're multiplying is the word of. So the word of. So what I'm going to think about whenever I model this is I'm going to be modeling 6 groups. And y'all bear with me, I'm writing with a mouse. Don't have a stylus. 6 groups of 2/3. So I'm going to shade 2/3, this fraction right here. I'm going to shade it 6 times. So I already have my empty grids right here. I didn't want to make you guys suffer through me drawing all of those. So those are already there. But let's say that you didn't have those there. You would draw 6 groups. And whenever you're splitting it apart, you know that there's 3 parts each. And then you shade 2 parts. So I'm going to change my color. So I'm shading 2 parts each. So 1, 2, 1, 2, and we're going to do it for each box that we have to represent 2/3 6 times. If I count up the yellow pieces that I have, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 parts, and the whole, so each shape that looks like that has 3 parts to it. So we get 12/3. And like we've done in the other problem, we simplified. We divided each by 4. And sorry, we divided each by 3, and our answer is 4. So if you ever needed to model a multiplication problem, this is how you would do that.